Hey everyone, I hope you are all well. The motivation behind this video is that almost every other tutorial I have seen where the user implements a 3D cube in their chosen language and programming environment, they somehow have an array of vertices ready from the get-go. They don't really explain how they got these positions where somehow a cube can be drawn. I hope the method used in this video clarifies the mystery, and all the references and the source code will be linked down in the description, or you can just copy the video as well. I think all the code is visible on the screen, so that's all I wanted to say for now. Let us begin. Before we get to 3D, first let's take a look at a 2D. The most important thing about this method are these 2 points, E1 and E2. They're called the basic unit points. Suppose we have a point in some position in this 2D plane. Our current one, which is A, is located here at 2 on the x-axis and 1 in the y-axis. Suppose we want to create a square from this initial point with a width of 1 and a height of 1. How do we do this? It's very simple. We simply add A to E1. This gives us a new point in the x-axis, one position to the right in the x-axis, which is now this point here at 3, 1. Okay, now we want to create another point. Now we have a point above from A at 2, 2. So as you can see, we've already created now a triangle. Let's create the fourth corner here of the square by simply adding A to E1 and E2. And there we have it. We have ourselves a square which is 1 squared. Each side is equal, the width and height are equal, and by using these basic unit points we have derived a square from an initial left bottom corner. So it's very simple to implement this in 3D, in 3 space. We simply introduce a third unit point, which is E3. Then by simply adding E1 on our initial point A, which is here at 1, 1, 1, we can get the 4 corners of a cube. Then it's simply a matter of connecting these points with lines and then doing operations like rotation and scaling to whatever size you want the cube to be. So we're going to implement that using Raylib to get a final product similar to this. This is an example that I've done a few days ago. It's available on GitHub if you want to see it. The one we make might be a little bit different, but the concept was just literally the same. So we're going to do this with Raylib. We begin by including the Raylib header file and creating an entry point for our program. We define the width and the height of the window, and Raylib makes it really easy to create your window. Next, we create our camera. It takes in a position. We'll just position it at the center of the screen with a bit of distance away from the center of the screen. We'll put our target to be the center of the screen. The y-axis is going to be up, so if you want to look from above, we simply increase the camera position's y value, and that's about it. Now that we've set up our working area, we start by defining our basic unit points, E1, E2 and E3, as well as the starting position of the cube. We'll just name it A and use our example from earlier, positioned at 1, 1, 1. Then I will create this simple vector 3 addition function, which simply adds 2 points together in 3 space and returns the new point. Then we simply use this function when we want to add A to E1, E2, E3 and the rest. Now that we've defined all our 8 corners of the cube, we can start plotting small spheres. That one was a bit too big, so we'll change the radius to about 0.1 and it should be perfect. Yes. So we'll plot these points as the corners of the cube and then use different colors for each one so that it makes it a lot easier to see which points need to be connected together. Now Raylib doesn't have a 3D line per se, but it does have a function which essentially does the same thing. Draw cylinder X simply draws a long cylinder between 2 points. And there we have it, our cube. Now that was too easy, so let's do a little scaling and changing the position of the cube to the center of the screen. If we change the cube size, then we also have to change our viewing angle to look from above. So now the y-axis have been increased on the camera position, so we look above from the cube. Then we simply center the cube. To do this, we create a variable center cube and set it to the cube size divided by 2. Then we simply subtract each position from the center of the cube, which essentially pushes the left side of the cube to the left and the right side will be pulled to the left. Then we can simply add that to the draw sphere function and it should center our cube right in the middle, Now, as you saw, the points were moved to the left of the screen. So now the points are in the center. We'll just disable the lines for now. We don't need them anymore. So we can start rotating each point along the y-axis. To do this, we'll use the rotation matrix for 3D, which is pretty simple. You can just look it up on Wikipedia. I'll post the image on the screen now. And essentially we apply this rotation to each point and then just add a angle to essentially rotate around. Oh yeah, I forgot to include the math library. Don't forget that, because you need that for the sine and cosine functions. And there we have it, a rotating cube in 3D in Raylib.